Hello and welcome once again to my 11 plus exam videos. More maths questions from specimen papers. Okay, so the first one is in the expression below we have 1, 2, 3, 4 and we have these boxes in between the numbers that have to be replaced by either a plus or a multiplication. The question is, what is the largest value of all the expressions that can be obtained this way? Now, right, so how do we do this? If we could put in a plus or a minus sign, plus or multiplication sign anywhere we want to and see what the largest values are. But bearing in mind that we are under time pressure, so we have to be a bit clever here. So if you add or multiply, if you multiply a number with 1, any number, 5 or 6, you get the same number. But if you add the number to 1 to that number, you get 1 more, so you get 6. So why am I saying this? The reason I'm saying this is because you have 1 here, so it will they have said what is the largest value. So to get the largest value you have to add 1 to the result of the multiplication, if that makes sense. Because if you add 2 plus 3 plus 4, you would get 2 plus 3 5 plus 4 9, plus 1 is 10, or 9 times 1 is 9. 9 plus 1 is 10. So that's why I gave you this example, that if you multiply a number with 1, you get the number itself. But if you add 1 to that number, you get 1 more than that number. Okay, so that is just for example and for understanding. So then how will we solve this? So we will do this. We will add 1 and it will be plus, then we will have 2, then multiplied by 3 multiplied by 4, that equals 1 plus 2 times 3, 6 times 4 is 24, and that equals 25. So what is the largest value of all the expressions? So the largest value of all the expressions is going to be 25. That is your answer. Okay, so if we move on to the next question. Now the next one is, a concert hall contains 2,800 seats. A model of the hall is made so that it looks exactly the same but 50 times smaller. Okay, it's just a model. If the hall is 100 meters long, how long would the model be? And the part B is, how many seats will there be in the model? Okay, so I'm going to do it this way. We have 2,800 seats in the hall and the model is 50 times smaller. So I am going to do 2,800 and I am going to divide it by 50. So what I get is, I get 5 times 5 is 25, and then I have 3, so it's 30, that's 56. Okay, so the 50 times smaller, then I will get 56 seats. So that is the part B, I think. So I don't know why I did this first, but anyway, so I think it has 56 seats. So the first one is, if the hall is 100 meters long, how long will the model be? So 2,800 seats is 100, so it's 100, because 50 times smaller, 2 meter. So I think that's your answer. So it'll be sorry, there's no need to write meter. So the hall, so I hope I got this correct. It looks too easy to me now. A concert hall contains 2,800 seats. A model of the hall is made so that it looks exactly the same, but 50 times smaller. Okay, so maybe that's why they have, that's why it catches. It's 50 times smaller. So, if the hall is 100 meters long, so and if something is 50 times smaller, how long will the model be? So you have to, it's only going to be 2 meters long, right? And how many seats will there be? So it's going to be 2 meters long, and there will be 56 seats, because again the number of seats will be less. There's nowhere they have said how many seats can fit in, so that sort of thing doesn't come here, I think. So my plain and simple maths says that it's 2,800 divided by 50. That's 56 seats. Okay, if you have any problems, if you do not agree, do leave a comment, please. Okay, let's go to the next question. Okay, this one tells a book has 256 pages with on average 33 lines on each page and 9 words on each line. Find an estimate of the number of words in the book. Right, so the book has 256 pages. Okay, so I have a book, there are 256 pages, and then there are 33 lines on each page. Okay, so if you put one below the other, 33 lines and 9 words each line. So if there are 33 lines, then words will be 33 times 9. Did we get it? So there are 33 lines and each line has 9 words. So 33 lines will have 33 times 9 words. And how many words in the book? So the number of words in the book will be 256 pages. So that is 256 times 33 times 9. Okay, so the final multiplication we need to do to find the number of words in the book is equal to 256 times 33 times 9. Now they have asked for an estimate, so we don't need to work that hard, but we will do a little bit of hard working. 256 times 33 times 9 we can do easily. 3 times 9 is 27. 7 and 2 is carried over. 3 times 9 is 27 plus 2 is 29. So this I can simplify. 256 I can make 260 times 297 I can say is 300. Estimate. This is an estimate. So I am working out the estimate. So they don't want the real answer. So they have made it easier for us. So 6 times 3 is 18. And 1 carried over. 2 times 3, 6 and 1, 7. 1, 2, 3. So there are 78,000 words estimated. Is that clear? I think that that's the answer. Okay. The next one is, what fraction of the shape is shaded? Then it says shade more squares so that 2/3 of the shape is shaded altogether. So what fraction of the shape is shaded? How many squares are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There are 15 squares. So the shape is divided into 15 squares. Out of it, 3 squares are shaded. So the fraction of the shape is 3 out of 15. That is the same as 1 out of 5 shaded. Okay, shade more squares so that 2/3 of the shape is shaded altogether. So 2/3. Okay, so what will be the 2/3? So we have to change the denominator to 15. 2/3 is 3 times 5. 2 times 5, that is equal to 10 times 15. So we have to shade 10 squares because there are 15 squares altogether. So if we know how many squares out of 15 we need to shade to get 2/3, that's why we did this equivalent fraction. So the trick here is, so we find the equivalent fractions. Okay, so this is the sort of trick in this question to get the equivalent fraction of 2/3, which is 10 out of 15. So I got to shade 10 more squares, total 10 squares, not 10 more squares. So 1 2 3 4 we have got shaded, have got 2 3. So 1 2 3 4 5 6 7 8 9, and this is already shaded. So these are your shaded squares. So then you get 2/3 of the shape is shaded altogether. You will do a better job at this than I will. Okay, it will be cleaner and neater, but this is how I'm just showing you how you're going to go around it. Of course, I assume you know it already and it'll be good for practice. Okay, anyway, let's move on to the next one. So next one is saying, what is the smallest possible difference between two different 9-digit numbers, each of which includes all the digits 1 to 9. Okay, how do we do this problem? So I think the way to do this is, now the first thing is we have to bear in mind, now what is the smallest difference between two numbers? Between two whole numbers, the smallest difference is 1. Okay, well, it could be 0, then the numbers are same. But the difference between two whole numbers, if the numbers are different, is 1. Assuming we are dealing with only positive numbers, we're not dealing with negative numbers. So the difference is 1. Okay, but that is if you only have a 1-digit. Now, if you have 2-digit numbers, again, well, it could be, difference could be, for example, you have 18 and you have 17. You can get 1 as a different. Right, now here, what is happening here? It's not just 18 and 17. It's not 2-digit. So it's 9-digit numbers. So let us continue with this. If we have this, now if I have here, if we have 3-digit numbers, what happens? So this is 9-digit. So let me have a little play around. If I have two 3-digit numbers, but then I can choose any digits, any 3-digit, right? And then my answer could easily be 1, like 3 to 1 minus, if I say 3 2, we can't say 0. So if I make it 3 2 4, and I have only 3-digit numbers, so wait, let me make it harder, then it'll be easier to explain. So if I have 3-digit numbers, say 1 2 3, so if I have only 3-digit number, and then these are the 3 digits, 1 2 3, and you cannot repeat the numbers. So 1 2 3 minus, if I say 1 3, no, that will be more, 1 3 2 minus 1 2 3. What's the difference here? It's 9. Okay, now how else can we rearrange these numbers? We can say 231 minus 213, but then it is more. See, because it is 8 and 3 11, then 2 1, that's 18. You could also write we have 1 2 3 3 2 1, then we could put 3 in front. Let's do it 3 in front. If you put 3 in front, we get 3 and 2 1 minus 3 1 2. Again, the difference is 9. Because what you see, what's happening is the lowest difference, the smallest possible difference, because they have asked for the smallest possible difference. The smallest possible difference you get is 9. It's not 1. You cannot get 1. See, this is the smallest we can, because we cannot repeat any number and there is no 0. So we are moving the digits, and we are moving the digits in the ones place and the tens place, because if you move the digit in ones place, you have 1 3 2. The next number has to be, it can't be to make it smallest difference, it has to be 1 2 3. There's no other combination you can have to make it smallest. I mean, it can be, that's the only way you can do it. So you see that 9, it is not, if it was 1 3 3 1 3 2, we could have done it, or 1 3 4 1 3 4, but we don't have 4. If we had 4, then it would be a 4-digit number, and again we'd land up in the same situation we have now. If you have only 3 digits and it's all, you have to use all the 3 digits, then 9 is the smallest difference you can get to. Okay, now I did a lot of talking just to explain what I think the answer should be. As you might have guessed, the answer is 9. 9 is the smallest difference. Now, let us write out all these numbers, the huge number they have given us, the 9-digit number. Let me write it down. So if you have something like this, if I may start with, instead of starting may keep it simple, 9 8 7 6 5 4 3 2 1, and then if I subtract 9 8, so I have to keep the rest of the numbers the same, and then 3 2 1, then I have to subtract 3 1 2. You see the difference is 9, isn't it? It can't be anything else. That's the smallest. Now you can try out any combination you like. You can have 1 2 2 3 4 5 6 7 8 9, and you can put in 1 2 3 4 5 6 7 9 8. Again it is 9. You can change any number here any way you like, but then you have to keep it smallest, or you would end up getting values here. All these values are 0. All these values are 0. So I think the answer is, what is the smallest possible difference between two numbers? It is 9. The smallest possible difference is 9. This is what my understanding is, and this is the way I have arrived at the conclusion. Okay, so if you think it's something else, please, I can always be wrong, but please do try, have a think about it. It's a good question. Okay, next one. So here are two number machines, right? So we have got two machines, okay, A and B, and both machines have the same input. Work out if the input, work out the input if both machines also have the same output. Right. So they have given us these answer choices. Okay. So, well, okay, let's do it my favorite way, that is n multiplied by 4 plus 4 equals x. This is my one equation. N multiplied by 5 minus 2 equals x. That is my equation number 2. Now if I subtract 1 minus 2, what will I get? I can always do 2 minus 1. I have just written 1 first and 2 next, so I am doing 1 minus 2. So I will get 4n plus 4 minus, I put a bracket, open a bracket, 5n minus 2 equals 0. X minus x is 0. Or we get 4n plus 4 minus 5n plus 2 equals 0. So if we change sides, 4 plus 2 is 6 equals n. So n is 6. So if n is 6, what is x? So 6 plus, sorry about that. What it is, so we get 6 times 4 plus 4 is 24 plus 4 is 28. 6, what am I doing? 6 times 5 minus 2 is 30, minus 2 is also equal to 28. 6 is your answer. Is that clear? I think it is. I think it is. Well, that concludes this session. Okay, we'll be back with more videos. Thank you so much for watching, and please like and subscribe if you find the videos useful. Thank you very much. Bye.